Hello and welcome to my YouTube channel Civil Line. Myself Milan Patel, Assistant Professor at LJIET Institute of Engineering and Technology. Today we will start a new chapter which is Civil Engineering Materials. This is the first lecture of this chapter. In this chapter we will discuss 20 different materials which are used in civil engineering like cement, steel, epoxy, optical fiber, smart materials, fly ash, soil, brick, concrete, mortar, steel slag, FRP, pipe, copper slag, timber, stone, aggregate, plastic, bitumen, and wire and cable. Today, in this lecture, we will cover first cement. Okay? In this, first we will discuss what is cement, then history of cement, then we will discuss essential components and chemical composition of cement. Then we will discuss manufacturing of cement. Then we will discuss various criteria for selecting good cement. Then we will discuss various properties of cement. And lastly, we will discuss various types of cement which are used nowadays. Okay, let's start with what is cement. You all have seen cement once in your life. Okay, it is made from mixture of elements that are found in natural materials such as limestone, clay, sand, and or shell. Okay, when cement is mixed with water, it can bind sand and aggregate into the hard solid mass which is called as concrete. Okay, now second topic is history of cement. In 1824, Joseph SPD, a British stonemason, heated a mixture of finely ground limestone and clay in his kitchen stove and ground the mixture into a powder to create the hydraulic cement, one that hardens with the addition of the water. Okay? A variety of sandstone is found in very large quantity in Portland in England. Thus, the cement is also called as Portland cement. Okay. In India, the first cement factory was installed at Tamil Nadu in 1904. Okay, by South India Industry Limited. Okay, this is the history of cement in India. Now, let's discuss various essential components and chemical composition of cement. There are four essential components of the cement. First is calcium, which comes from limestone. Okay. Second is silicon, which comes from sand. Third is aluminum, which is mainly comes from bauxite. Okay. And last is iron, which comes from iron ore rocks. Okay. The chemical composition of cement looks like this. Okay. In which the main component is lime. Okay. Which is called as CaO, calcium oxide, having percentage 62%. Okay. Generally, the range of this lime is between 62% to 67%. Similarly, the second highest component or ingredient in cement is silica, which is also called as SiO2, silicon oxide. Okay, the average percentage by weight of the silica in cement is 22%. Okay, its range is about 17 to 25% based on various companies. Okay, that's all about the various ingredients in the cement. Okay, now let's discuss how this cement is manufactured. Okay, manufacturing of cement. There are two processes depending upon whether the mixing and grinding of raw materials is done in wet or dry conditions. Okay, first is dry process and second is wet process. The systematic diagram of manufacturing of cement looks like this. Okay, in which first limestone, clay, and iron powder grind together. Okay, which creates one raw material, which is then heat up at 1450 degrees centigrade, which converts this raw material into clinker. Okay, this clinker and gypsum then grind together to make the cement. Okay, in this cement, additionally, some mixing materials are added like fly ash, silica fume, etc. Okay. In this process, the following operations are involved. First is mixing of raw materials, second is burning, third is grinding, and fourth is packing and distribution. Okay, these are the processes involved in manufacturing of cement. Here, the clinker looks like this, gypsum look like this. Okay, by grinding these two, we make the cement. Okay, that's all about the manufacturing of cement. Now, let's discuss various criteria for selecting a good cement. Okay, the color of the cement should be uniform and greenish gray. Okay, this is the first criterion. Second is it should feel smooth when touched or rubbed between the fingers. Okay, it should feel cool when insert the hand into the dry cement bag. Okay, it should free from hard lumps. Okay, it should not be moist. Okay, and it should not contain excess amount of silica, lime, alumina, alkalis, clay and silt. These are the criteria to be considered for selecting good cement. Okay. Now let's discuss the properties of cement. The properties of cement is of three types. First is physical property, second is mechanical property, and third is chemical property. Let's discuss physical properties of cement. There are four physical properties. First is fineness, second is soundness, third is consistency, and fourth is setting time. So what is fineness? Let's discuss. Okay. The fineness test of cement is done by sieving a cement sample through standard ISC. You can clearly see the ISC. Okay. The weight cement particle whose size greater than 90 microns is determined and the percentage of retained cement particle are calculated. This is known as fineness of cement. Okay. The procedure of this test looks like this. First of all, we have to take 100 grams of cement sample and not its weight, which is used as W1. Okay. Second, drop 100 grams of cement in 90 micron sieve and close the lid. Okay. Then we have to shake the sieve with your hands by agitating the sieve for 15 minutes. Okay. For that, sieve shaking machine is used. Okay. After that, take weight of retained cement on this 90 micron sieve, which is W2. Okay. To calculate the fineness of the cement, we have to use this formula W1, which is the cement sample which we have taken 100 grams. Okay. W2 is the retained cement which is on the 90 micron sieve multiplied by 100, which gives the fineness of the cement. Okay. This is how fineness of the cement is calculated. Second test is soundness test. Soundness of cement can be defined as its ability to retain its volume after getting hard. Okay. This means that a properly sound cement will undergo minimum volume change after it converts into the hardened state. Okay. The apparatus used in this soundness test is LJIET apparatus. Okay. The expansion by LJIET apparatus should not be more than 10 millimeter. Okay. You have to make one mortar. Okay. In this LJIET apparatus. After hardening of this mortar, cement expands. Because of this expansion, these two wires expands. Okay. We have to measure the distance between these two wires. It should not be more than 10 millimeter. Okay. Third test is consistency test. The standard of consistency of cement is that consistency which permit the wicked plunger to penetrate to a point of 5 to 7 millimeter from the bottom of wicked mold when it's tested. Okay, this is the wicked mold. Okay, you have to pour one mortar in this wicked mold. Okay, and then we have to drop this plunger from the top. Okay, the plunger penetration should not be more than 5 to 7 millimeter from the bottom of the wicked mold. Okay, when tested. By consistency rate, we can find optimum amount of water to make cement paste or cement mortar. Okay, so you have to use different water cement ratio for this consistency test. Okay, that's all about consistency test. Fourth is setting time test, in which also wicked mold apparatus is used. in which we have to calculate initial setting time and final setting time of the cement paste. Okay. For that, we have to calculate the time required when 1 millimeter needle inserted till 5 to 7 millimeter from bottom of wicket apparatus. This time is called as initial setting time when cement paste starts hardening. Okay. Initial setting time should not be less than 30 minutes for ordinary Portland cement. Okay. Final setting time is the time when cement paste has hardened sufficiently in such a way that 1 millimeter needle makes an impression on the paste in the mold, but 5 millimeter needle does not make any impression. Okay. So you have to calculate that time for calculation of final setting time. Final setting time should not be greater than 600 minutes or 10 hours for ordinary Portland cement. That's all about the setting time test. Okay. These are the 4 physical properties of cement. Now let's discuss mechanical properties of cement. There are 2 mechanical properties. First is compressive strength and second is tensile strength. First we will discuss compressive strength of cement. The mortar of the cement and sand is first prepared, having proportion 1 and 3. Here 1 is the cement part and 3 is the sand part. Okay. Then water is added to the mortar. Okay. The water cement ratio should be kept as 0.4. This mortar is placed in various molds and molds are placed in damp cabin for 24 hours. The molds which are used in compressive strength of cement is having size 70.6 mm by 70.6 mm by 70.6 mm cube molds. Okay. The specimens are then removed from the molds and submerged in the clean water for curing. Okay. After curing, the cubes are then tested in the compression testing machine at the end of 3 days, 7 days and 28 days. Okay. This is how you can calculate the compressive strength of the cement. Okay. The equation used for compression strength of the cement is maximum compression load, which is shown in this CTM compression testing machine, divided by the area of the cube, which is 70.6 mm by 70.6 mm. Okay. This is how you can calculate the compressive strength of the cement. Now let's discuss tensile strength of the cement. Okay. For that, first we have to make a mortar having proportion 1 and 3. The water is added to the mortar having water cement ratio 0.4. Then mortar is placed in molds and molds are placed in damp cabin for 24 hours. Okay. The molds which are used for tensile strength of cement is looks like this. Like it's a shape having briquette. Okay. The specimens are then removed from the molds and submerged in the clean water. Okay. After curing, the briquettes are then tested in compression testing machine, which is shown earlier. Okay. At the end of 3 days and 7 days. Okay. The equation for calculation of this tensile strength is failing load of this briquette divided by the cross sectional area of this specimen. Okay. This is how you can calculate tensile strength of the cement. These are the 2 mechanical properties of cement. Now let's discuss the chemical properties of the cement. For chemical properties, first of all you have to find out various chemical composition of the cement. Okay. And then check various parameters. Like first parameter is ratio of lime to silica, alumina, iron oxide should be greater than 1. Okay. Second is ratio of alumina or iron oxide should be greater than 0.66. Third is magnesia should be less than 5%. Fourth, insoluble residue content should be less than 1.5%. Fifth is sulfur content should be less than 2.75%. And loss of ignition, okay, of the cement should be less than 4%. These are the chemical parameters of the cement. That's all about the properties of the cement. Now let's discuss the last topic in today's lecture, which is types of cement. First type of cement is ordinary Portland cement. Second is Portland pozzolana cement. Third is quick setting cement. Fourth is rapid hardening cement. Fifth is high alumina cement. Sixth is blast furnace cement. Seventh is low heat cement. Eighth is white cement. Ninth is colored cement. 10th is sulphate cement. 11th is expanding cement. 12th is hydrophobic cement. 13th is waterproofing cement. And 14th is acid resistant cement. Let's discuss these all 14 types one by one. First is ordinary Portland cement, which is also called as OPC. It is a common variety of cement. It is suitable for construction of all civil engineering works except underwater construction. Okay. Various uses of ordinary Portland cement are like this. It is used for preparing cement mortar for masonry work, plastering and pointing work. It is also used for preparing concrete for casting floors, roofs, beams, columns, lintels, stairs, etc. It is used for construction of heavy structures like dams, bridges, tunnels, etc. Okay. It is also used for construction of roads, water tanks, septic tanks, etc. It is used for manufacturing precast concrete blocks, pipes, piles, fencing posts, etc. And it is used for construction of foundations, footpaths, watertight floors, etc. Okay. This is the simplest cement having no additional material in it. Okay. That's all about ordinary Portland cement. Second is Portland pozzolana cement. This is also called as PPC. Okay. It is manufactured by intergrinding of OPC clinkers and 15 to 35% of pozzolanic materials like fly ash and slag. Pozzolanic materials are essentially siliceous or aluminous material which does not have cementitious properties, but it is in very fine form and in the presence of water react with calcium hydroxide to form cementitious properties. Okay, so initially this pozzolanic material does not have cementitious property, but after adding water it reacts with calcium hydroxide to form cementitious properties. Okay, PPC does not give high strength at early age compared to the OPC, but it gives later age strength. Okay, it is economical compared to OPC because we have added 15 to 35% of this pozzolanic material like fly ash and slag. These are the recyclable material having lesser cost compared to the cement clinkers. Okay, it gives good durability compared to OPC. Okay, so it is very long lasting compared to ordinary Portland cement. Okay, it gives more volume of mortar compared to OPC because having lesser size of particles of fly ash and slag. Okay, that's all about Portland pozzolana cement PPC. Now let's discuss the third type of cement, which is quick setting cement. As the name indicates, it sets very fast. Okay, the early setting property is brought out by reducing the amount of gypsum during the grinding process. So to make this type of cement, we have to reduce the content of gypsum. Okay, this cement is costlier than ordinary Portland cement. Initial setting time starts within 5 minutes after adding water. Okay, the ordinary Portland cement having initial setting time is about 30 minutes. Here, quick setting cement has initial setting time is quick setting cement has initial setting time of 5 minutes. Okay, final setting time is within 30 minutes. Ordinary Portland cement has final setting time of 10 hours. Here, final setting time is 30 minutes. Okay, it ground much finer than OPC cement. Okay, it is used for underwater construction and grouting operation. Okay, for plastering works. Okay, that's all about quick setting cement. Fourth is rapid hardening cement. The name itself suggests it hardens very fast. Okay, this cement contains more percentage of C3S content and less percentage of C2S content. Okay, the high strength at early age is due to final grinding as fineness of cement will expose greater surface area from the action of the water. Okay, the strength obtained by this cement in 3 days is equal to the strength obtained by OPC in 7 days. Okay, so it is called as rapid hardening cement. Initial and final setting times are similar as OPC, which is 30 minutes and 10 hours. It is generally used when time is most important factor in the project. Okay. Fifth type of cement is high alumina cement. It is manufactured by using raw materials like limestone and bauxite. It is characterized by its dark color, high heat of hydration, and resistance to chemical attack. It is useful against corrosive action of seawater. Okay, so it is generally used near and along seashore structures. Okay. Sixth type of cement is blast furnace cement. For this cement, slag, which is obtained from blast furnace, it is the equipment which is used in steel making industries. Okay, so slag is the byproduct of this steel making industries. Okay, so slag is added into the cement to make blast furnace slag cement. Okay, it has slow rate of hardening and less heat of hydration compared to OPC. Okay, it is not affected by seawater and can be used for marine structures near the sea. Okay, the seventh type of cement is low heat cement. Low percentage of tricalcium aluminate C3A and silicate C3S and high percentage of dicalcium silicate C2S is used to manufacture this low heat cement. Okay, it has very low heat of hydration during setting as well as hardening. Okay, very slow rate of developing strength as rate of C3S content is very low. Okay, so developing strength is very slow compared to OPC because of this C3S content. It is generally used for massive concrete structures like dams where excessive amount of concrete is used, which can produce excessive amount of heat, okay, which can develop various cracks in the structures at the initial stage. Okay, that's all about the low heat cement. Now let's discuss the eighth type of cement, which is white cement. It is produced by mixing OPC with pure white color produced with white chalk or clay from iron oxide. Okay, as iron oxide gives grey color to the cement, it is therefore necessary for white cement to keep the content of iron oxide as low as possible. Okay, white cement gives milky or snow white appearance. Okay, it is costly and only used for interior decoration and some finishing type of works. Okay, it is not used for normal construction of slabs, beams, columns, etc. Okay, that's all about white cement. Next is color cement. It is produced by adding various pigments in the regular cement. This pigment should be durable under light, sun or weather. Okay, it is used for making top layer in flooring, paver blocks and other decorative purposes. Okay, that's all about color cement. Next is sulphate cement. The sulphate cement is made by adding ground blast furnace slag and calcium sulphate into the OPC. Okay, the heat of hydration is considerably lower than the OPC. It also resists various sulphate attacks. Okay, it is generally used in marine structures as well as mass concrete works like dams or bridges. Okay, next is expanding cement. Okay, this cement is produced by adding an expanding agent like sulfoaluminate in it. Okay, this cement expands and volume increases where other cement shrinks and volume decreases while setting and hardening. Okay, this type of cement is generally used to neutralize the shrinkage cracks, okay, of the concrete made from ordinary cement, so as to eliminate cracks. Okay, a small percentage of this cement with concrete will not let it crack. Okay, so it can also be added into the cement to reduce the cracks in the building. Okay. It is separately desirable for hydraulic structures to make structures watertight. Okay. In repair work, it is essential that the new concrete should be tight fitting in old concrete. Okay. This can be done by using this expanding cement. Okay. That's all about expanding cement. Now, hydrophobic cement. The name itself says, okay, hydro means water and phobic means against. Okay. Hydrophobic cement is obtained by grinding Portland cement clinker with a film forming substance such as oleic acid or stearic acid. Okay. These chemicals form a layer on the cement particle and does not allow water to mix and start hydration process in the transportation or storage stage. Anyhow, during the mixing process, due to great agitation, this layer of water repellent break and allows the hydration to take place. Okay. It is generally used in longer storage periods and extremely wet climate conditions. Okay. That's all about hydrophobic cements. Next is waterproofing cements. It contains waterproofing agents during its grinding process. Okay. It is more impermeable and more resistant to chemical attack. Okay. That's all about waterproofing cement. Last is acid resistant cement. It has high silicates and thus has high resistance to acids. Okay. So it has very high silicate content. It is generally used for lining of acid storage tanks in number of industries and also used for joining acid-proof bricks and tiles. Okay. It is also used for construction of acid-resistant industrial flooring. That's all about various types of cement. Okay. I hope you all understand what is cement, history of cement, various essential components and chemical composition of cement, how cement is manufactured, what are the various criteria for selecting good cement, various properties of cement, physical, mechanical and chemical properties of cement, and lastly, we have covered 14 various types of cement. See you soon in the next lecture. Thank you for watching. Don't forget to like, share and subscribe to my YouTube channel, Civil Line. Thank you.